everyone. Welcome to the Icebox. I'm going to try and talk fast so we can all go outside and warm up. Hi, my name is Sam. I am based in New York City. I'm a data insights engineer. I used to work for Flatiron Health. A lot of you probably know about the company. I spent 5.5 years there analyzing oncology data. My background is actually in academia, in knowledge representation, automated reasoning. So I've done a lot of data modeling, data representation. Sort of on the theoretical side, and then at Flatiron, I spent 5 years just like basically wearing every single hat you could possibly imagine, from data engineering, software engineering, automation, data QA, customer research, developing analytical packages, spinning up web platforms, pretty much anything. My expertise is like less in big data, so everyone always talks about big data. It's more like artisanal, handcrafted data, and it's also less focused on like actual data science. So I don't do like heavy machine learning stuff, but more about subject matter expertise and really sort of data understanding. You can follow me on Twitter at spbale. I'm pretty active there. Cool. So how did this talk come about? I am literally quoting my own tweet here. I went to a machine learning conference earlier this year, and I heard a lot. It was really funny because it was kind of a split between sort of two types of speakers. One group was from academia, and they said, "Oh, look at us! We built this awesome model with this data," and they were really excited about it. And then there was sort of the Friday afternoon slot was more like healthcare data scientists from industry. And they said, well, this is all really difficult and it's kind of brutal. And you really need domain experts to understand what you're actually doing. And your users probably won't trust you. And adoption is really hard. And I thought it was such a funny contradiction between the two different types of experience that I decided to sort of share my own experience that I've had at Flatiron Health. And generally working in healthcare data over the past 5 years. So just for the structure of the talk, I'm going to first of all just give you a very brief overview of what I consider to be the vision of healthcare data and AI. Talk about problem number 1, which is messy data. Problem number 2, reluctant users, which is, at least from my perspective, one of the things that we sort of coming from, and I just assume most of us will be coming from like a technical background. People from a technical background don't always think of. And then finally sort of give you the light at the end of the tunnel and talk a little bit about path forward to get out of that mess. So, the vision. I, for one, welcome our robot overlords. So this is a very, very simplified version of what I consider to be sort of the general vision, maybe for people either coming from a clinical background who are not that deep into technology, or sort of the general public, or also a lot of people in technology who kind of get their hands on data and think, oh my God, I can solve this problem, this is going to be amazing. So you have a patient has some ailment, patient goes to see a doctor, there's some diagnostics, lots of measurements. That all generates a lot of data, right? Then we throw this at some wonderful AI algorithm, whatever the AI flavor of the day is. Based on that, the patient gets recommended some form of treatment, whether that's surgery or drugs, for example. Usually that sort of iterates like in a cycle where the patient gets treated. So my background, sorry, just as a sideline, I worked in oncology, cancer treatment, and usually for cancer treatment, it's not just you take one drug for like a week and then you're done, but it's a very cyclical sort of treatment where you have cycles where you get like chemotherapy infusions, for example, once a month or every few weeks over the course of several months. So in that context, you get your treatment that has some impact on the patient. There's more diagnostics, right? You take more lab tests to see has the tumor, for example, grown or shrunken. What's the blood values look like? And that generates more data, and then you can plug into the AI and see maybe there's a new treatment, or maybe this treatment is going great, right? At the same time, we also assume that all this information that feeds into our data set, whatever this nebulous data set is, also then gets shared, and so we can learn from that for other patients. So that's actually what Elias in the keynote just talked about, kind of this whole like having a population and then deriving some entailments from that population for the individual, right? So this is sort of the general hope that we have for artificial intelligence in healthcare. And then obviously at the end the patient is cured, and ideally if this feeds into sort of a bigger data set and bigger learning system, lots of other patients will be cured based on that too. Cool, so that's a hope. One of the most prominent examples, at least from my perspective, again, kind of with an oncology lens, over the past few years, everyone's probably heard of IBM Watson. IBM Watson is a very, very prominent example of sort of people having really, really high hopes about this whole learning from, in that case, mostly from literature, and then recommending treatment for patients and improving treatment outcomes. Starting in 2011, over 50 organizations, and this is, let's take this with a grain of salt. This is me just counting sort of press announcements. But around 50 organizations announced collaborations with IBM Watson by 2017, again, based on the data that I have. If anyone is here from IBM Watson who has better numbers, please do tell me, please do correct me. But from what I've seen, from kind of what I clicked around and researched, only about 5 projects out of a sample of 24 that I looked at had actually been launched. So there's a lot of high hopes and not a lot of actual implementation, or not a lot of actual sort of production. There's an app in the UK, it's called Babylon Health. So for context, I used to live in England, so I'm also very interested in the NHS and things that are going on across the pond. Babylon Health is a patient-facing app that provides an AI chatbot to triage symptoms. So if you do work in healthcare, you're probably aware that one of the kind of topics that's very interesting for people in healthcare is avoiding or preventing hospitalizations. Having people go to hospital, to the emergency room, is extremely expensive, and in most cases, or in a lot of cases, actually not necessary. So we want to try and avoid that. So having an AI chatbot that can triage symptoms and then tell people whether they really need to go to the emergency room, or whether they can maybe stay at home or just wait until they can see a general practitioner the next day, is an extremely helpful measure. Babylon actually has 2 contracts with the NHS in the UK, so there seems to be a lot of recognition that this might actually be helpful. But also physicians actually voice concerns about the accuracy of those diagnoses, and depending on whether you have false positives or false negatives in that case, you can have sort of, either you're wasting money or you're potentially putting someone's life at risk. So regardless of whether whether you have false positives or false negatives, in that case, wrong diagnoses are actually just pretty bad. So to just sum up sort of the introduction, there's been a lot of hopes. There's a ton of other examples that I can name you. Just one thing for you to think about, and maybe I'm just really missing the thing here, but I asked a bunch of people as I was preparing the talks, what's the killer app that's in production, that's already sort of the industry standard for healthcare and artificial intelligence? And I didn't really get any answers. If anyone can actually name me one thing that's the go-to, that's already in production, that's been proven and tested, please do let me know. But it's sort of, I feel like everyone's dancing around it and really excited about it and has a lot of hopes. But there's no killer app just yet. So from my perspective, there are 2 sort of types of reasons as to why these high hopes just didn't really turn out and positively in reality. First of all, there's a lot of technical challenges around healthcare data in particular. And then secondly, there's also user acceptance challenges. And next 20 minutes or so, I'm going to talk you through those 2 aspects. So healthcare data is hard. Let's go shopping. If anyone can guess where my quotes are from, please do talk to me. Cool. Okay, so for the purpose of this talk, I have a working definition of healthcare data because there's a lot of things you can imagine there. For my purpose, this is any kind of what I call real-world data that is generated as part of a patient's and clinician's interaction, and that could also involve other people, but I'm focusing mostly on patients and clinicians, with data capturing software and medical devices, for example, medical records, so electronic medical record systems or electronic health record systems, the software that your doctor uses when you go and see a doctor to document anything related to what's your disease, what's your blood pressure, your BMI, what kind of medication are you currently taking, what are they prescribing you. All these things are stored in an electronic medical record system, electronic health record system. I use them interchangeably. Any sort of scans, for example, lab and pathology reports, billing records, chat interaction, if there's chatbots with your providers, for example, device data, Fitbits, of course, are like the most famous one there, et cetera, et cetera. So that's my definition of healthcare data is real world data, basically. One big thing, the reason why I'm saying that is because a lot of times when you think about healthcare data, you also think about things like drug discovery, for example. That's the sort of pile I won't be talking about, mostly because I'm not an expert in that, also because it's a completely different world, obviously. So real world data is sort of my definition of healthcare data. Cool. All right, this is my favorite part. Like I said, I spent 5 years just like trying to figure out how to deal with all this stuff. So I'm like very excited to tell you about how awful healthcare data is. This is group therapy for me. Great. Okay, so first of all, when we have healthcare data, we have something we call structured and unstructured data. By structured data, we mean discrete database fields. So if you look in the database and it says first name or last name or social security number, you expect to find exactly those things in there. This gets really fun when the supposedly discrete fields allow free text. Because once you allow free text, they will be used to enter free text, which means your field that says, for example, lab result might not actually contain the result in a numeric value, but it might see something like, so we looked at this and we've done the first test, and the first test resulted in X, and then the second test resulted in Y, just because there's not a lot of enforcement of what actually goes into these fields a lot of times. And then we have unstructured data, which is scanned letters, for example. A lot of healthcare communication still happens via fax. So we get a lot of faxes, lab reports, like I said, faxes, and physician notes. So physicians also like to just sort of write free text. Mr. X is a very pleasant 56-year-old man who presented with XYZ symptoms, et cetera, et cetera. I actually have an example of that. So this is the kind of what we call visit note, for example, or physician note that you find a lot of times in electronic medical record systems. And this is clearly like very unstructured text. Cool. The second one, that's also sort of the bane of my existence, gaps in data. And honestly, like for me, coming from a background where I spent a lot of time integrating data from external resources, where you basically have no idea what people are going to do with that external source. Sort of the classic data science, we generate our data in-house. We're looking at log files or click rates on our website, sort of like in e-commerce, for example. That's a beautiful, sort of that's greener pastures. This is sort of the real world where you just have to kind of accept the stuff that you get, and you have absolutely no control over it. So one of the reasons why, specifically in healthcare, a lot of times you have gaps in data is because patients tend to see multiple clinicians. Either they might get a second opinion somewhere, right? Or they might just switch clinicians because they're not happy with one, or they might move. Or in oncology specifically, we have something we call snowbirds, which is people who sort of during the summer live in sort of the north and like say Illinois and like colder climates, and then in winter migrate down to Florida, for example. So you have people who continue treatment, who continue to see physicians, and they might just have different locations they visit. Totally normal. The problem is if you rely on that data for your analyses, you'll have gaps in there. And a lot of times you might not even know that you have the gaps, right? EHR migrations. So the EHR field is very, there's a lot of development. I do have a couple of sentences about like sort of the history of EHR development, but basically clinics just change their EHR systems because they don't really care about sort of data consistency and the data from like 5 years ago for patients that they might not be seeing anymore. So a lot of times they switch from one piece of software to another piece of software and just throw away all the old data because they don't care about it anymore. Based on my experience, we had to do a lot of convincing, a lot of work to get practices to keep any data that's even older than 2 years, because they said, we haven't seen this patient in 2 years. We don't want the data. What are we going to do with it? And we had to convince them to say, well, you can keep it. It's not going to make your system slower, but it might make life easier for us. So just keep that in mind. Like a lot of times, the people who are generating the data for you don't actually care about the data, and they're happy to just throw it away. And the last thing is workflow changes. Again, something you have no control over. That happens a lot in healthcare. You might have, for example, you might stop seeing infusion data for an oncology clinic. So they do chemotherapy infusions on site. You see drug administrations, drug infusions just happening and being documented every day. And then one day they just stop. Why is that? We literally had to get on calls with the clinics and ask them, so what happened there? Why are you not documenting this anymore? Oh yeah, we just signed a contract with another site, and all our patients now go to this other infusion site to get their infusions there, and they're using a different system, and that works for us because we don't care about the data. So those kinds of things happen too, which is, again, you have no control over. And the interesting thing in that case is it's not like, oh, our database crashed and we have to bring it back up from a backup and then everything is fine again. No, it's literally this data will never come back. Like it stops, and all the future patients will go to another site, and that's it. Like, and those are the sort of like gaps that you have in data that you A, have to detect, and then B, once you know that's the case, what are you going to do with it? And it's a really tough question. So just as an example, I kind of talk about the patient journey a lot. This is just sort of a contrast of what's happening in the real world and what you might be seeing in the database. And like, I'm not a doctor, so please do take this with a grain of salt. This is just based on what I've seen in oncology. So what is happening? You might have done some tests done at the primary care provider, which is sent to an outside lab. The patient gets a referral to Clinic A. Clinic A does more tests and then diagnoses the patient. The patient gets treatment and recurring tests at Clinic B. Clinic A, for some reason, like I said, for example, might just move. Patient continues treatment at Clinic B. Patient might be hospitalized and then might even be referred to hospice. Also, as a side note, working in oncology is actually kind of sad. Sometimes you look at the data, but you do see the people behind it. And occasionally it's a little hard to deal with. So this is what you might see in the EHR of Clinic B. So assume you have a contract with Clinic B to actually integrate their data, to do some data analysis on that. So you don't see anything from the primary care physician. You don't get any reason for the referral. There might be a mention about this, about what happened previously in a visit note at Clinic B. Might be backfilled, the date might be off, the data might be off, you're not quite sure, right? The physician just sort of entered that. There might be a mention in a visit note about the treatment that happened at Clinic A. Then if you do start getting data from Clinic B, that's great. There's recurring records and visit notes. You might get another mention of a visit note about the hospitalization, but generally there's no interoperability between sort of smaller community practice and hospitals, so that data might also just be mentioned somewhere or not. And then you might also never find out about the referral to hospice, so the data just sort of ends that you see. This is terrible, but also pretty typical. This is kind of like the patchiness of the data that I've seen in the past. Third, we have data silos. So data is physically hard to access. A lot of times you have an oncology clinic or a community clinic that has a computer with the database, with a SQL Server database or something that runs the EHR that runs on the 3 computers at the practice. That's pretty much it. How do you get that data? From my experience working at Flatiron, one of the things that we did is we literally had physical boxes there that basically provided a proxy for us to access to then pull the data. And believe it or not, people pulled the plug on those boxes too. So those are the kinds of things that you have to deal with, this like actual physical access. There's necessarily no data model or coding standards. So if you manage to integrate data from, let's say, EHR A at hospital A, and then you want to do the same thing at hospital B with EHR B, it might just look completely different. I'm saying no in air quotes. There are data standards in healthcare for, it's called HL7, for example, for sending messages. I have a lot to say about that. It enforces sort of the format of the data, like the structure, but again, in the same way as a field that says lab result might not necessarily contain the exact lab result that you're looking for. In the same way, HL7 might not enforce the actual content of the fields necessarily. And due to all this, scaling beyond a single institution is really, really hard. So you kind of just have to take it one place, one database, one physician at a time. I'm just going to mention this. This is kind of ambiguity in medical text and acronyms, abbreviations, longitudinal data, sequences is really hard. This is one thing, obviously, honestly, where I think this is exactly what computers and machine learning and all that is there for, to like figure out ambiguity in that. That's kind of what we're good at, right? Like once we have the data and then actually trying to understand what's there, if we know the data is like fairly complete and everything, that's sort of, more of a technical problem that we can actually solve. And then lastly, I'm sure a lot of you, if you're in healthcare, you've heard about HIPAA. We can't just dump data into the cloud. There's a lot of extremely sensitive data. There's a lot of concerns. You can't just, Slack someone, hey, can you look at patient XYZ and see what's going on with that data set? It kind of looks weird, right? Like there's a lot of, even just for like a typical sort of data analytics workflow, there's a lot of barriers to data sharing, for example. Linking data sets and mapping entities is really limited. So you have one data set and then you want to, let's say, link it to another data set. That usually requires a lot of times in order to map entities, in order to link data for the same person. You actually need their personal information of some sort. That you can't do, right? It's really hard. It's not like you have, let's say, click data for that person that's kind of logged into their browser on one website, and you can easily link it to another profile on another website based on their email address. Like that, you can't do. And then finally, like I already said, like sharing and validating data is really hard because you can't just like Slack someone an entire patient record and say, hey, does this look cool to you? Very quick sidebar, how did we get there? Why is healthcare data such a mess? EHR adoption, so electronic health record systems, are extremely new. We're literally just at the beginning of the adoption. This came kind of with the High-Tech Act in 2009, which is sort of part just of an economic stimulus after recession in order to encourage EHR adoption. So this whole technology, it's been going on for a really long time, but mass adoption has only come in the last 10 years, so it's super new. And it encouraged EHR adoption, so physicians would get incentives for actually using electronic systems to document all their data. But no one really cared about interoperability at the time. So it was kind of like, cool, you all go and use the system and use your computers for that. And then we'll figure out what to do about it later. The main reason for that was because data and machine readability was mostly an afterthought. It was really just about interoperability in terms of, oh, this is all in a computer now instead of a physical file, so we can send the whole document to another person at another hospital. This is awesome. This is solving all our problems. It was really just intended for people to send it electronically. It was never meant for anyone to actually, for anyone, and by that I mean for any computer, to actually interpret it. I keep calling it glorified paper. It basically is that. Like, it's great that it's not on paper anymore. You don't have to fax it, but you can email it. Problem solved. Also, one of the things that's really pains me to see occasionally, because we are so extremely spoiled when it comes to UX in terms of consumer applications like Facebook and my iPhone and new Mac OS. Everything just works so well and so seamlessly. If you see physicians using electronic medical record system, you see them painfully just clicking and clicking and clicking and using drop downs. And you know, it's all, I explained this talk to a friend of mine a couple of days ago and say, they're still using horizontal scroll bars. I grew up with the internet in the 90s, and horizontal scroll bars even then were like the worst possible thing you could do. But to me, it sort of describes like how backwards some of the technology is. And the interesting thing is, because the clicking is so hard, this encourages dictation, which again kind of takes away from like the niceness that is discrete data to just having full text that might just be messy. And then finally, there's also no incentive for physicians to actually document anything in structured form if it's not needed for billing. Why would they they didn't go to med school to type things into a computer, they went to med school to treat patients, right? And this is actually going to be the topic of the next part of this talk, is sort of like, how do physicians interact with electronic medical record systems? So TLDR, getting clean and reliable healthcare data as input for any kind of analytical application is really hard, and scaling data access and standardization across a single institution is also really hard. So going back to my initial tweet, every time I saw all these academics talking about, so we implemented this thing at our hospital and this is great, I was like, this is awesome and this works exactly for your hospital and probably nowhere else, because any kind of infrastructure that you have to actually get the data and process the data, and any kinds of assumptions that you have about the shape of the data won't work outside of this institution that you've built it for. Cool. I am running very late. Okay, other problem, reluctant users, aka white doctors hate their computers. This is the title of a really amazing article that I read. I'm going to sort of breeze through this, mostly just based on quotes from some amazing articles. So first of all, data entry is slow, so I've already mentioned it just now. One doctor in this article says, most days I will have done around 30 to 60% of my notes by the end of the day. So if you think about it, it means that computers actually increase the workload of physicians. There are some studies out there about increased burnout rates, for example, that are sort of linked to increased workload, which is linked to increased adoption of computer systems and an increased need for documentation. Alert fatigue is a really huge problem. In an ideal world, again, thinking sort of with our machine learning hats on, it'd be amazing to alert physicians and clinicians. For example, if someone is at a risk of sepsis, the number of people I've talked to who've implemented sepsis warning or sepsis alerts in their hospitals, it must be double digits at this point. It's a very popular topic, but the question is sort of how many alerts do we really need? As an example, so this is a fantastic book called The Digital Doctor, and there's a description of how an EHR system was implemented at a hospital, and of 350,000 medication orders per month, pharmacists were receiving pop-up alerts on nearly half of them. Like, means 50% of the time, anything you do, you get a pop-up alert. If you all use computers, you all know how annoying pop-up alerts are, and at some point you're just going to start ignoring it, right? One fantastic point that I heard from Carrie Amberg from Engine, who actually talked at MLConf, which kind of inspired this whole talk. She said, great, we now have AI to detect more spinal fractures, but is our hospital actually equipped to deal with more detected spinal fractures? We now have to treat and diagnose even more patients. Like, do we even have that? So insights and then what, right? Like, and again, coming from like a technology perspective, you're like, oh my God, we can alert all these people of all these amazing things. But then what happens? This is where we touch the real world, and the real world, unfortunately, moves extremely slowly, and you have to talk to a lot of people, and you have to build a lot of infrastructure and processes and operations around sort of implementing actions based on your insights. And then finally, also again, one of the problems, I think, especially with ML, that a lot of people are starting to get more aware of is sort of the black box problem or transparency, explainability. a lot of times, especially when you aim at users that are not necessarily technology natives, they'll be like, where does this come from? Like, why should I believe your algorithm, right? Again, from my perspective, maybe sort of something that we're already thinking about and maybe a problem that we can actually solve with technology. Cool. So the TLDR for this is really, it will take more and continued effort to convince clinicians that computers are helpful, not just painful. Like I said, it's only been 10 years. It's only been 10 years since EHR systems have kind of taken off. I should probably add like a little graph to this to actually show how it's sort of exploded all over the scene. This is an extremely new field, which seems kind of crazy because you kind of think this is not a big deal entering, data into a computer. This has been going since, the 80s or 90s. But just keep that in mind that like technology in healthcare is actually a fairly new field, and it's difficult. Finally, path forward. So don't give up just yet. I basically told you guys like don't even bother. Ad tech, it's the way forward. No, so there are paths forward. This is my very biased and very sort of personal sort of view and perspective on where I see opportunities for healthcare data and AI. I've actually split it into how to deal with the technology or the messy data problem, the technical challenges, and then also how to deal with sort of like what to do on the user side. So first of all, on the left-hand side, this is a very busy slide. On a technical side or on the data side, be prepared. Like, expect inconsistent data. I hope that from all the horror stories that I've just told you, this is kind of sunken in. Like, don't expect your data to just work. If it goes down, like, don't expect it to come back up. It's not something that you can just talk to your data engineer to and be like, hey, can you just reboot that server or like restart the database host? No, that database, someone might have unplugged it and it might never come back. So one of the things that from my perspective, I think helps there is like building an actual really strong data engineering culture, not just sort of the data science side where you sort of inspect your data to just be there and functioning and nice and pretty, but really think about monitoring, think about alerting, think about data QA, think about data assertions. I was really excited about the talk earlier today about Great Expectations, the data assertion framework, because that is really something that in an environment that's as brittle as healthcare data is absolutely mandatory. So you want to detect and prevent data issues. The other thing there is also when I'm talking about QA, you need subject matter experts on there. We engineers think we're really smart. We kind of are, but we have no idea about any kind of medical topics. So please do work with your subject matter experts to really tell you whether your assumptions are actually and your assertions are actually right. And then also have a plan B. If your data source changes, if your data just disappears, if they pull the plug, if your clinic gets acquired by a hospital and move to a different system and that data ends, how do you handle that? How do you deal with that? Like you just have truncated data and what are you gonna do with it, right? So that's sort of the technical side, is like actually be really prepared. On the user side, this is more sort of about the applications that I think have a future at this point in healthcare data and AI. One of the big things, and I'm sort of, if you look at these two together, practice workflows and administrative tasks, they're very, very similar. This is not decision support. This is not anything clinical. It's not telling physicians how to treat their patients. It's not telling the patients like what treatment is best for them. This is really just addressing a lot of the pain points around the administrative aspects of healthcare. Mostly because anything like cost management, benefit management, insurance, just figuring out, is your insurance going to pay for this? On the clinic side, there's something called revenue cycle management, helping clinics actually just manage their finances, things like that, that allows people to free up their time and actually focus on their treatment. From my perspective, and also from my experience, what I've seen, these are the things where the users are extremely excited to get help because it's really painful and it's not what they went to med school for. And this is something where there's like a huge space where you can really make a huge impact. Things like value-based care, for example, predicting and reducing hospitalizations, I think is also sort of again, there's a lot of, a lot of people trying a lot of different things, but I do think there's a path forward here for artificial intelligence. Triaging on the patient side, so again, it's sort of the same, like a very similar thing, right? Predicting hospitalizations sort of on the clinic side, having like nurses, for example, call up patients and saying, hey, you should probably come in for a check-in because you're high risk for something. On the patient side, triaging in terms of the patients actually have a way to sort of get some feedback on their symptoms before they go to see a doctor, before they go to the ER. That seems like a fairly low risk to some extent, mostly because, again, like I said earlier, false positive. If you tell someone to go to ER, you might be wasting money, but at least you're, you're potentially saving someone's life. So if you're aiming for false positives rather than false negatives there, you might be on the safe side. It might be fairly low risk, and there's a lot of data out there. Image processing, just throwing that in because it's a very, very popular topic, and it has actually, so radiology, like assessing radiology image, there's been extremely good numbers. There's been extremely good results. Also because, from my perspective, at least radiology is sort of slightly outside of the whole like clinician talking to a physician sort of realm. And it's more about they're already staring at their computer all day. I actually got to see a radiology room, and it's so cool. They're literally sitting in a dark room just looking at images all day. So having some form of computer support there won't be as intrusive as like having it in the examination room where a physician really just wants to talk to a patient and not stare at a computer. And finally, I think mental health, especially around like lowering barriers and reducing stigma, for someone to admit, oh, I'm going to see a therapist, or even just looking for therapists, is extremely challenging occasionally. Downloading an app like Talkspace doesn't use any AI in there. It uses AI for patient matching, I think, to therapists, but it doesn't necessarily use AI in terms of like actually conversation. But there's something called Youper, for example, which actually uses a chat bot. I tried it out, and it's surprisingly good. So things like that, I think, just lower the barrier for people to get any kind of access to mental health care. I think that's an interesting, like extremely interesting path forward for artificial intelligence. Lots of information there. I'm more than happy to chat about all this later. I have office hours right after the break. I think that's it for me. We made it.
Talk about like from a data organization perspective, like other countries like UK has it easier because it's more standardized, and also maybe US like remote, it's an easier access to remote because it's all of that one system.
That's a fantastic question. So from a data organization perspective, I talked about how everything is like sort of diverse and dispersed and sort of messy. Are there other countries, for example, where systems are more standardized? So I know about the UK, and that was my hope, and I kind of assumed, oh yeah, NHS, they have all one system. Interestingly, the NHS is all split into regional subgroups, and they can determine what kind of system they use. So I actually talked to an engineer at the NHS, and she said the data is just as messy as the stuff you're describing about the US. There are initiatives, and obviously because the NHS is a unified system, those initiatives are, more potentially could be more effective, but there's also been one that's already shelved that totally failed to kind of unify all the data. So part A is that, and then you're talking about hospital systems, I guess. So hospital systems versus individual practices, that is definitely totally an option in terms of, or it's definitely better in terms of having a unified system and potentially even having a unified, like a single place where the data is stored. One of the problems with hospital systems is that a lot of times they don't just start out with, these are exactly the sites that we have, and we implement our EHR system across all these sites, and then we're done and nothing changes. But a lot of times they actually grow by acquiring practices, and then we basically face that EHR migration problem where some of the practices move to hospital systems and move to their EHR and then just throw away the old data, and then you're kind of missing historical data. Also, it doesn't necessarily guarantee that they're using the same system. There's specialties, for example, that might actually stick with other systems. So potentially better, but still, at least based on my experience, not reliably great. Could still be messy. Yeah, great question. I think, yeah. Or maybe, I don't know if you're...
So do you have any success stories you can share about cases when you faced one of these issues and you managed to handle it?
Ooh, great question. I'd have to, that's a fantastic question. This is also negative. I'm sure we've had success. So the question was, do I have any success stories of any of these issues where we actually fixed it? I'd have to think. Happy to think and then talk to you at office hours about this. Sorry. Great question, though. Great point. I should be more positive. You had a question?
So, probably trying to put a slightly more positive spin on it. I also work in healthcare data, and I think you talked about this, which you said like anything that's not designed for billing. Now, the counterpoint to that is things that are not designed for billing should have to be much higher quality data because they describe that data. And so, within healthcare, there's really many different data types that you can work with: lab data, claims data. And so if you do start working with those data types, you have a variety of other challenges. There's it's not all like unicorns and roses, but at least you're dealing with different types of things.
Yeah, that was a great comment about again the positive, potential positive aspects. Depending on the type of data, so specifically, the gentleman specifically mentioned billing data, that might actually be of much higher quality because if the billing data is not complete and accurate, no one will get paid and people would want to get paid. So the quality there is usually very high. The problem that I see with billing data specifically is that it's not very interesting from a clinical perspective because you might, so for billing data, for example, you might not get the lab results or you might get an ICD code, a diagnosis code that says lung cancer. And ICD, the International Classification of Diseases, which is a coding system for diagnoses, medical diagnoses, does not distinguish between small cell and non-small cell lung cancer, for example, which is a very common distinction you have in oncology. So it's things like that where it's kind of, you have complete data, but now the medical depth is not very interesting depending on your use case. But that's a great point. There are different types of data sets, and depending on the use case and depending on the needs, different data sets are useful for different purposes.